The hydraulic cylinder in the figure shown has a bore diameter of 125 millimeters. What minimum pressure in the hydraulic cylinder would be required to hold a load of 50 kilonewtons at the angles shown? First, begin by converting the 50 kilonewtons to newtons by multiplying by 1,000, which equals 50,000 newtons. Determining from the question and the graphic that this is a third-class lever, use equation 2.13 to solve for the equilibrium force. F1 times L1 is equal to F2 times L2. Since the units in the question are metric, use the metric equation to calculate. Looking at the question and the graphic and determining that F1, L1, and L2 are provided, solve for F2. The equation can be rearranged to solve for F2 or the equilibrium force. F2 equals F1, which is the applied force of 50,000 newtons, times L1, the applied distance, which in the graphic is 6, divided by the equilibrium distance also provided in the graphic of 3. Calculating those numbers, the equilibrium force F2 is equal to 100,000 newtons. Now that the equilibrium force is known, use equation 3.7 to solve for the cylinder load. The force of the cylinder is equal to the perpendicular force divided by the sine of the angle theta. In this case, the angle is 45 degrees. Using the equilibrium force we just calculated of 100,000 newtons and dividing it by the sine of theta, which the graphic depicts as 45 degrees, which is equal to 0.707, remember, you can calculate the sine of theta or use the charts provided in the math book to determine the sine of a 45-degree angle. The equation now becomes 100 divided by 0.707, determining that the force of the cylinder is 141,421 newtons. Next is to determine the cylinder area using equation 2.8. The question provides the bore diameter of 125 millimeters. Plugging that number into the equation, 125 millimeters squared, which when calculated equals 15,625, times the constant of 0.7854, gives an area of 12,272 square millimeters. Now calculate the pressure using Pascal's law, or equation 2.1. Since the force and the area are known, rearrange the equation to solve for pressure. The equation now becomes pressure is equal to the force divided by the area. Since we calculated the force of 141,421 newtons, that's divided by the area that we calculated of 12,272 square millimeters, that provides a pressure equal to 11.52 megapascals.